Hi, Assalamualaikum warahmatullahi wabarakatuh. Today in this video, we're going to learn about the circular measure, in which we see in circular measure we learn about basically about circle, and this is just kind of revision because you have learned this in your additional mathematics during your secondary school. Alright, so firstly, we need to know how to convert from degrees to radian. But before that, you should know that 180 degrees should be equal to pi radian. So that's the formula that you have to remember. And then when you want to convert the from degrees to radian, right, you are given 180 degrees to equal to pi radian. So meaning to say that if you want to have 1 degrees, meaning to say that you have to divide with 180. Therefore, in this case, you have to divide with 180. So when this one can be cancelled out, so you will have 1 degrees, which is equal to pi over 180, right, radian. But if you want to have, like, for example, if you want to have like 4 degrees, so what you have to do is you have to multiply 4 with this one, because 1 degrees is equal to this one. So of course, when we want to have 4, so 4 should be multiplied with this. So you got the your approximation of the radian. All right, so that's the angle in radian from degrees to radian. Almost in similar way, but from radian to go to degrees, so you should write, because you know that 180 degrees should be equal to pi radian. Therefore, pi radian should also be equal to 180. Therefore, if you want to have 1 radian, so what should you do? You should divide both sides with pi. All right, so you will have 1 radian should be equal to 180 degrees divided by pi. So if you want to have 2 radians, so what you should do is actually multiply 2 on both sides. So multiply 2 here. Therefore, now I have 2 radian should be equal to, all right, that one should be 260 over pi. And the same way, if you want to have, like, for example, you want to have 3.5 radian. Therefore, you should multiply here with 3.5. All right, here should be multiplied with 3.5. So that's basically how to convert from degrees to radian and from radian to degrees. But the most important thing is that you have to know, you have to memorize that 180 degrees equal to pi radian. That one will make it easy for you to convert from degrees to radian and also from radian to degrees. All right, the next thing that is very important in this topic is actually the arc length. All right, so this one is the formula for the arc length, S. Right, so we know that S is here. You can see obviously that S is the arc here. All right, so which is the length from this to this. All right, so that is the arc from this to this. So that one is S, given by the formula S equal to R theta. And we have the formula for the area of this. Like, for example, you want to have the area for this what do we call sector. All right, you have this sector, so you have the formula that A equal to half R squared theta, but with one condition, that both in this case theta should be in radian. So if you're given with questions that give you theta in degrees, therefore you have to convert from degrees to radian using this formula. All right, let's look at some examples here. Suppose we have if the circle has a diameter 11 centimeter, so you are given with the diameter, so you should know that the radius, right, the radius here should be divided by 2. So 11 divided by 2 should give you 5.5 centimeter. And theta is actually 1.92 radian. So theta is actually 1.92 radian. And we have to find the arc length of the minor sector POQ. So you have 2 sectors here, right? So you have sector POQ. The minor sector is actually on these sides. Since this is the minor sector, so this is a sector, but it is a minor sector. But if the question asks you to find the major sector, meaning to say you have to find the one that is POQ, is also POQ over this side, but it is a major sector. So be careful when you read the question. So read carefully whether it asks you to find the area of the major sector or the minor sector. So this is actually the major sector. So be careful with this one. Right, in this case, we want to find the arc length of the minor sector, meaning to say that we are going to find the length which is here. So S, right? So this is the arc length of the minor sector. So you should know that the formula is actually given by, all right, for the first one, which is easy, s equal to r theta. You have the radius, so be careful when you are given with the diameter, you have to find the radius. So the radius is actually 5.5. You should multiply with the theta, which is in radian already, which is 1.92. So when you press your calculator, 5.5 multiplied with 1.92 will give you actually a 10.56 centimeter. All right, next one. Let's look at the second question. Right, so okay, the second question asks you to find the area of the major sector POQ, meaning to say that we are going to find the area on this side. So do you have the angle at the major sector POQ? We don't have the angle here, so you have to find the angle here first. So in this case, let's look at the second question. To find the theta in this case, all right, you know that if pi radian is actually equal to 180 degrees, so for a circle, it should be a 360 degrees, meaning to say that you have a 2 pi radian. So in this case, our theta should be 2 pi minus, all right, because we just want to have this part only, so we have to 2 pi for the full circle, we should subtract with this one, 1.92. Right, so 2 pi minus 1.92, all right, so will give us, all right, actually 4.3232, all right, 4.3232. Usually for this topic, we will round off it to 4 decimal places, all right, so our 4 significant figures for it to be safe for it. So you have 4.3232 at the for the theta over here, so you have 4.3232 over here, and you have to find the area of the major sector, so you have to use the formula for the area, which is given by, all right, so area is actually given by half r squared theta, all right, you already have the radius, which is 5.5, you square it, and then you multiply with 4.3232, so that one will give us, all right, multiply, okay, 4.3232. So I got the area for the major sector, which is 65.3884. This one is actually centimeters squared because it is an area. All right, so that's how you use the formula for the arc and also arc length and also the area. All right, let's look at this example. Suppose we are given with this actually, all right, so sometimes the equation give in form of a sentence, all right, sometimes in form of this diagram. So you have the radius, which is 3, and you have the length with the arc length, all right, which is actually 3.141, and you need to find the angle theta, all right. We need to say that you have to use the formula because you already have the r and you have the s, and you are going to find theta, therefore you have to start with the formula, which is s equal to r theta. Therefore you substitute the value of s, which is given by 3.141, and r is actually given by 3, and theta, which is actually you are going to find theta. Therefore theta is actually 3.141 divided by 3, all right, so 3.141 divided by 3 will give us actually a theta 1.047. That one is actually in radian. All right, next we need to find the area, all right, so we need to find the area of the minor sector, means we have to find the area of this sector over here. We have the formula for the area, which is actually given by half r squared theta, all right, so half r is actually the radius, which is 3 squared, and theta we have just found it is actually given by 1.047. Therefore using your calculator, all right, 3 square multiplied by 1.047, I've got my area, which is given by 4.7115 centimeters squared. All right, so that's my area for that region. So because we need to find the minor sector, so the minor sector is the smaller one. All right, so that's it. Next, let's look at this example. All right, so it's quite interesting for this example. We have the figure. We choose 2 sectors. Actually, we have 2 sectors here. So this is the first sector and the second sector, which is given by that, the bigger one. All right, we have the center. So they share the same center. Given that AB equal to CD, which is equal to 3, so AB and C, I think AB and CD. It says that AB and CD. All right, I guess I have copied the AB. Yeah. You've got AB and CD, 3 and 3 here. I'm sorry. Okay. AB and CD. All right, 3 and 3 over there. Okay, AB and CD. All right. So you already have the length for AB and CD. And we are given with the AOD is just given by 0.95 radian. And the perimeter of ABCD, all right, ABCD is actually given by 25. All right. So, we just need to find the length of OD and OC. All right. So for this case, actually, we can use the formula for the arc length. All right. So let's say we don't know this one. Okay. All right. We actually don't have the value for the what do we call OD here. So I just put it X. All right. So we should see that the length from here to here is actually given by X. And the length from this to this is given by X plus 3. I hope you see that clearly. Because for this one is actually given by X. And for the second one, which is given by X plus 3. That's why we have this one. Alright, so now you have to deal with this kind of algebra. Right, so you have right now that the length. Okay, let me just start with the given perimeter of this, which is given by 25. So I have the length AB plus BC plus CD plus AD is actually, or DA, all right? It's actually 25 because that's the perimeter. Now, I already have the AB, which is given by 3, plus with BC. All right, so how do I find BC in this case? So we have to use the formula for the arc length, which is given by S equal to R theta. Our R is radius, is for the bigger one. So of course, this one is the radius because we want to find this arc length. All right. So now we have R, which is given by X plus 3, and theta is actually 0.95. Okay, so this is S is actually the length which is for BC, right? So I have that one as, all right, 0.95x plus with, all right, so 3 multiplied by 0.95 will give me 2.85. Right, so I just copy it here. So 0.95x. So it is in terms of x now. 2.85. All right. Next one. For the CD. All right. I already have the value for the CD, which is plus 3. And for the DA is actually the one that I'm going to find its arc length. In this case, we have that the arc length for this one. All right. So which is given by, all right, so still we have to use the formula for S equal to R theta, and our S now is actually the length AD or DA. All right, R is actually given by X because the radius for this one is actually X, this length. All right, so X multiplied with 0.95, so I have 0.95X. So for DA I have 0.95X. Right, so that's the summation, and it should be equal to 25. All right, I hope you get the idea on how to solve this one. Right, that one should be equal to 25. All right, next one. What we need to do is actually to combine all these, what do we call, numbers. These constants can be added together. All right, so that one will give me 8.85 plus with. Right now I'm going to combine the algebra. In this case, this one with this one. So I have 0.95 plus with 0.95. All right, so I'll get 1.9x. So I have, all right, 1.9x. That one should be equal to 25. So this one is actually a linear equation. How to solve this one? So of course we need to bring the 8.85 to the right side. All right, so I have something like this. So when I subtract 8.85 from 25, that one will give me, all right, so 1.9x is actually given by 16.15. So how to find x? Of course I have to divide 16.15 together with 1.9. So the one should be divided with 1.9 will give me actually 8.5 centimeter. So we already obtained the length for OD, right? In this case, X is actually from O to D. So this one is X. So I've already obtained OD, which is given by 8.5 centimeter. As simple as that. All right, so what about OC? So from O to C, so of course, X plus with 3. In this case, OC 8.5, I have to add with 3. Because this one is 8.5 and this one is 3, so I add them together. This one will give me 11.5 centimeter. Yes. All right, so that's OD and OC. Next, we need to find the area for the ABCD. All right, so what you need to do is actually to find, all right, the area. All right, so basically I already have the all right, let me just sketch it here. All right, we know that the length here which is actually given by 8.5 from these to these, and the length from O to C is actually given by 11.5. So that is easy for me to kind of find the area of the shaded region. So of course, to find the area of the shaded region, we have to find the area of the bigger one first. So the area, formula for the area is actually given by half r squared theta. So half r squared theta for the bigger one, all right? So look at the bigger one. So of course, we need to focus on this one. That one is for the bigger one. So I have half 11.5 square multiplied with theta, which is 0.95. That one is the area of the bigger one. I have to subtract. All right, so I have to subtract the area of the smaller one. So why I do this? All right, because that's basically we find the area of the bigger one, we subtract the area of the smaller one. So of course, this one will give this part, something like that. All right, okay, something like that. Okay, we cut out that one. Okay, so now in this case, I have obtained actually this one is half, all right, area of the smaller one, 8.5. The radius is actually 8.5. I have to square it, so I have 0.95. All right, so you can find the area of the first one. All right, half multiplied with 11.5 square multiplied with 0.95. This one will give me 62.81875 minus 0.5 minus 8.5 square multiplied by 0.95. This one will give me actually 34.31875. So I subtract them. All right, 875 minus that one. So this one will give me the area which is given by 28.5 centimeters square. So that's it. I hope you get the idea on solving this one. All right, next one. Let's look at this one. All right. Okay, I think this one is the second last. I hope I can make it faster. OAB is a sector with this is actually 0.5 radian. C is the midpoint of OA. So C is the midpoint of OA. So meaning to say that the length here is actually a 4. All right, 4 centimeter. And the area of the shaded region is actually a 10.5 centimeter square. Find the length of the OD. Right, so to find the length of OD, we have to work a little bit hard for this one. And we should know the properties of the triangle, right? So actually later we will learn on this topic, which is a solution of the triangle. But you have to know the area of, suppose we have, like for example, here is A and here is B and here is C, angle C. So the area of this triangle is actually given by half AB sine C. With one conclusion, with one condition that C should be between A and B, right? It should be in between. All right, now to solve this one, all right, so we have to find the area of the, what do we call? Of course, the area of the largest one first. So let me find the area of this one, okay? Area of this sector. So area is actually given by half r squared theta. Half r is actually 8. Why? Because the length from that to that is actually given by 8. 4 plus 4 will be 8 squared. And then theta is actually a 0.5. So this one is given by, okay, 0.5 multiplied by h squared multiplied by 0.5, 16. The area of the sector is actually 16 cm square. But now we are going to subtract with this one, the area of this one. So the area of the triangle should be given by, all right, so 4, this one is, let's say I put it as x, and 0.5 is here, all right. So the area, all right, should be given by half using the formula of this triangle. AB, A is 4 and B is x, all right. So 4 multiplied with x multiplied with 0.5, sine 0.5. But make sure your calculator, right, to use this sine 0.5, make sure your calculator is in radian, because now 0.5 is actually in radian. If your calculator is in degrees, so make sure it is converted into radian, all right? So now, to multiply with sine 0.5, this one will give me actually a 0.9589x, right? 9589x. I've got this one. All right, so, you know, if you subtract, right, so suppose this one is A1, this one is A2. If you subtract A2 from A1, all right, A1 subtract A2, you will get the area of the shaded region, all right, so which is given by 10.5. That's the condition or given in the question. Therefore, I want to subtract 16, subtract that 0.9589x, I will get 10.5. all right, so I'll get 10.5. I hope you get the idea, because I have this one and then I subtract this triangle from this sector, therefore I've got this shaded region. Okay, that's the idea. All right, so now what we have is actually something like, all right, so 0.9589x is actually given by 16 minus 10.5. Be careful with this linear equation, all right? So if you are not able to solve this slowly, then please do it slowly, all right? So that's basically what I do. I bring this to this side and this one to this side, therefore I have 0.9589x. So now it's something like that, all right? So I have x, which is given by, all right, 16 minus 10.5 is actually given by 5.5. So this one should be divided by 0.9589. All right, so 5.5 divided by 0.9589, this one will give me x, which is equal to 5.7357. Yes, x 7357 centimeter. All right, so what is x? So actually I label this one as x. So x is actually the length from O to D. So that's what we are finding. All right, OD is actually 5.7357. all right, but the idea is you have to know this area of the triangle should be given by half AB sine C, with one condition that the angle C should be in between A and B. All right, so let's look at the last one here. Suppose we have this figure and radius is actually 7. All right, so of course this one is 7. Okay, now and the theta is actually 130 degrees. All right, so simple. If you want to use the formula which is given by s equal to r theta and half equal to r squared theta, therefore you need to convert theta from 130 degrees to radian. So you should know that 180 degrees should be equal to pi radian. Therefore 1 degrees should be equal to pi over 180. So you want to have 130 degrees, therefore 130 multiplied with pi over 180. Right, it's simple as that. So 130 multiplied with pi divided by 180. This one will give me, right, 2.2689 radian. Right. So that's 2.2689 radian is the angle theta. We need to find the length AB. Alright, so actually this one is quite confusing. Alright, because it does not mention which AB should we find. Actually, right, suppose we have to find the arc. So of course, the arc of the minus sector, right? So let's say this one is the one we're going to find, AB here, right? So let's assume that one. So that's very easy. So we have to use the formula for S, which is given by r theta. All right, r is actually 7 and theta, which is 2.2689. Therefore, that one will give 2.2689 multiplied with 7. This one will give me 15.8823 centimeter. That one is the length of the arc AB. Area of the shaded region. All right, so how to find the area of the shaded region? The idea is to find the area of this sector, and then we find the area of this triangle, and then we cut out. So this one minus this one will give me this one. All right, so of course for the first one, all right, so let's say A1 is to find the area of this sector. All right, so A1 is actually half r squared theta. This one is given by half r is actually a 7 squared theta is actually a 2.2689. All right, so this one will give me, okay, what is that? 0.5 until 7 square multiplied by 2.2689. So this one will give me 55.5881 centimeter square. So that's the area for A1. Now we are going to find the area for A2. So area for A2, still, if you can remember just now as a previous example, we have a triangle which is ABC, which is the, what do we call, the angle between them. So of course we need to use the formula for half AB sine C, which is A is 7 and B is 7, right? So 7 and 7, and this is the angle, so we have to take sine C is actually all right, you can choose 130 should be in degrees. If your calculator is set in radians, so you can write 2.2689. All right, so you can find this area, multiply with 2.2689. All right, should make sure that your calculator should be in, what do we call, your calculator should be in radian. All right, 7 multiply with 7 multiply with sine 2.2689. This will give me 18.7685. Okay, 18.7685. So to find the area of the shaded region, so area of the shaded A1 minus A2. So I've already obtained 55.5881 minus is 18.7685. All right, so I've got the answer by pressing your calculator. And the last one, perimeter of the shaded region. So the area of the shaded region, we already have the AB, but we need to find the length here. So actually we have to use the cosine rule. All right, cosine rule, because we have something like this. All right, but you have not learned this, never mind, I'll just ignore the third example. Maybe we can see this in the next subtopic, right, for this chapter. Right, so that's it for this video. All right, I hope you do a lot of exercises on the different kinds of the questions solving problem or for the circular measure. All right, so that's it for today. Thank you for watching this video.